Hey guys, we're going to talk about how to model quadratic functions using graphs, and we're going to look at the tables and try to come up with some vocab we're going to come across in the Regents exam. Alright, so I got the graph up for our exercise 1, and then I'm going to make sure first I'm in graph table, which I am. So then hit second graph. Okay, now I'm not going to see the whole graph because the numbers are going to be pretty large. So for my graph here, I have, for the domain, the numbers between 0 and 6. So I'm going to start at 0. Then we got 0, 80, 1, 128. We got 2, 144. And then we have 3, 128. 4, 80. And moving down to figure out those other ones are, you got 5, 0. So I'm going to connect these. And this was part C of the question, but having that graph is going to help us with the other parts. So first off, it says evaluate h of 0. So when the time is 0, the height is going to be 80. So h of 0 ends up equaling 80. And it says explain the physical significance of this. This is the point where they release the projectile. So at 0 seconds, we're at 80 feet. And that means that at 80 feet, the projectile is released. So imagine it being on top of a building or something like that. Now it says to determine algebraically the time when the ball hits the ground. But for the sake of what we're doing right now, we're looking for when it equals 0. And in this case, it's going to be at 5 seconds. So at 5 seconds, the projectile hits the ground. And then we're going to kind of move down. And then for part D, it says, what is the maximum height of the projectile and what time does it reach that height? So moving back up, the maximum height would be our vertex in this case. And that vertex is at 2 seconds. The projectile is at 144 feet. So that kind of covers a lot of the main parts of this. And you'll see these on the Regents where they want you to use the table mostly. But they also might ask you to create a graph from it. So we're going to move down to exercise 2. And this is going to be the last one that we're going to look at together. Now it says, why does a quadratic model seem most reasonable? And again, a quadratic model is going to look like a U shape, whether it's opening upwards or downwards, kind of like I drew on the paper. So in the case of this, it says, the question's about popcorn. It says the optimal temperature at which it pops. And they're trying to study the percent of popcorn that pops at that temperature. So what you're going to see is as we move up the graph, from 38 to 68 to 78, they're increasing. And then after we get to that optimal temperature, it starts decreasing from that point. So we're increasing in each of these cases, and then we start decreasing. So the model seems reasonable because of that table. The table increases. Then it reaches a maximum. Then it decreases. And we talked about the vertex form a little bit. It says if the equation for the popcorn is measured by that, then what temperature is the greatest percent of popcorn popped? So in this case, T is the temperature. So in the parentheses, this right here would represent that the temperature would equal 450. and that at that point, the greatest percent of popcorn at a temp at 450, we would have 82% of popcorn popped. So again, you need to make sure you read the question carefully, and also make sure that you know what the variables represent, because they're not always going to be x and y, kind of like with these two questions. Okay. So please get started on the classwork questions on the second paper, and then work on some of the test prep.